Okay, we're going to talk about conditional probability, and we're going to do so using tinkerplots and Excel. So here's the problem. The test correctly identifies a disease in 99% of people who have it. It correctly identifies no disease in 97% of people who have it. And in the population, 2% of the people have the disease. So we are going to start by simulating this in tinkerplots. So here I have tinkerplots, and I'm going to grab a sampler here. The first thing I'm going to do is I'm going to divide the population out into whether they have the disease or they don't. And let's see here. We know that, let's look over here, 2% of the people have the disease in the population, so I can change this to 2%. The other one changes to 98% automatically. Now what we're going to do is we're going to layer this, because if you have the disease or you don't, you can still have the test. So the next layer is going to be the test. So I'm grabbing a spinner, I'm going to drop it to the right, and there are two possibilities. Either I have the disease or I don't. So let's label these. In the first layer, this is the disease, whether you have it or not. And then the next layer, this is going to be the test result. And so now each one of these is either going to have a positive or a negative test. So let's fill those in. Positive result, negative result. Okay, and we follow the lines here. So if I had no disease, let's look. The test correctly identifies no disease in 97% of people who don't have it. So I don't have it. It correctly identifies the disease in 97%. So my negative tests here should be 97%. It correctly identifies the disease itself in 99% of people who do have it. So if I have the disease, 99% of those people should have a positive test. Now, what this says is it's going to draw two. It's going to spin one here and then one in one of these two. And let's just repeat that a couple thousand times. So I'm going to do that like 2,000 times. And let's see what's happening. So it spins whether or not you have the disease, and then randomly assigns whether or not you get a positive or negative result, depending on which one of these categories you are in. So let's speed that up. All right, I've got my 2,000 results. Let's just push things out of the way a little bit here. So we can really do three different very interesting plots that tell us very different information. Let's just look at the test results first. So here's the test results. I got two different color plots. I got positives and negatives. Let's stack them, count them, get the percents, and I'm going to turn these into rectangles so I can see them a little easier. So it looks like on my test results, I had 6% positive result, 94% negative result. Okay, let's look at the disease itself. I'm going to plot that guy, separate those out, stack them, count them, get the percents, and turn them into something a bit more readable. So it looks like 2% of the people actually had the disease, 98% did not. No big surprises there. And now I can also look at the joined results. And this one's a little bit more interesting. If you look closely, there are four different colors here. Now I'm just going to start separating these guys out. Okay, because there were four different possible results. So let's stack them, count them, find the percents. I'm going to change them into rectangles so I can see them a bit better. Okay, so now we're ready to estimate a few probabilities. So back over here. We'll go to this in just a second. Let's see here. The probability of having the disease given a positive test. That's what we're interested in. Having the disease given a positive test. So if I come over here, the disease and positive is 41 people. There's that one. Now that's having the disease given a positive test. So out of the people that had positive tests, notice this is labeled in two different colors. So that's 41 out of 116. So there's about a 35% chance, that's what our estimate is. So I'm going to say about 35%. Okay, what about the disease given a negative test? So disease and negative, that's one person. Negative test, that's 1,884 people. So that's 1 out of 1,884. Wow, that's really small, 0.0005. So we'll approximate that to small. Really, 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 really small. Having the disease if you get a negative test is unlikely. Now we can run this again. So we run 2,000 more. Notice I didn't get any in this category that time. And we can run it over and over and over, and we'll get different results. So let's look at this one. If I want to estimate this guy again, the disease with a positive test, or given a positive test, that's 30 people out of 95. Well, that's a 32% chance, which is a little bit less than our estimate from before. Tinkerplots is good at making estimates for us. So we've done the simulations and we've made some estimates. Okay, now let's go to Excel and see what's going on here in Excel. I've already split this up and I've said let's let 10,000 people come into this test. We know that only 2% of them will actually have the disease. So if our population is 10,000 people, only 2% of that will have the disease. The other 98% will not. Now, if you have the disease, you have a 99% chance of getting a positive test. So it's 99% of those people will have a positive test. The other 1% of those people will have a negative test. Now, if you don't have the disease, you have a 97% chance of getting a negative test, and you have a 3% chance of having a positive test. So if I do a little bit of summing here, so we got 492 positive tests in my 10,000, 9,508 negative tests in my 10,000. We could always do this by dividing out by 10,000 on all of these. So I could just say this is that number divided by 10,000 and drag that up. And now I know what the probabilities are here. I could also do this by saying, well, I've got a 99% chance of a positive test in the disease group. I've got a 1% chance of a negative test, a 3% chance of a positive test in the no disease group, and a 97% chance of a negative test in the no disease group. So let's look at how we can calculate these exact probabilities. Probability of the disease given a positive test. Well, I could say that is, I have the disease out of, let's see here. If I have a positive test, so let's see, probability of having the disease out of a positive test, that should be these guys, because these are all the ones that had a positive test, and that's about 40%. And our Tinkerplot's estimated about 35. I bet you if we did it again, we'd probably be above 40. Okay, what about having the disease given a negative test? Well, let's see, that is, I've got the disease and a negative test out of all those people that had negative tests. And that's really, 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 really small. So that is exactly in line with what we had. Okay, what about the probability of a true positive test? A true positive is you have the disease and you get a positive test. Well, that's those folks out of everybody. Pretty darn small. Now we've got that right here as well. What about a false positive? A false positive is I get a positive test, but I didn't actually have the disease. So that's those folks out of everybody. We got about a 3% chance of having a false positive. What about a true negative? A true negative is I don't have the disease and I get a negative test out of everybody. Or a false negative is I have a negative test but I actually had the disease. And of course, if I add those guys up right there, they sum to 1 exactly as I expect them to. And that's it. This is an example of conditional probability. We've looked at the problem from contingency tables, and we've looked at the problem from estimating with tinker plots.